Guys, welcome to my new video. In this video, we're gonna talk about k-means clustering algorithm. K-means clustering algorithm is an unsupervised learning algorithm that helps us find k number of cluster in a given group of dataset. It's one of the most simplest and one of the most common algorithm for clustering. As you can see in this picture, we have three distinct clustering that we can identify from our naked eyes, but machine cannot identify this. So we use k-means clustering algorithm, which will convert this dataset which does not have any pattern to a dataset something like this. It has three distinct cluster that can be used for further identifying the pattern. So in this video, I will be walking through all the steps involved in k-means clustering algorithm. If you are confused about any of the step, you can feel free to jump to that particular step via the timeline. But if you are not sure about how the algorithm works and unclear about a lot of things, I would highly recommend you watch all the video till the end. So without any further ado, let's get started. So the overall k-means clustering algorithm is divided into five steps. First one is defining k or number of cluster. Second is randomly placing the k centroid in the dataset. Third, for each point in the dataset, we need to find the nearest centroid or cluster and assign them. In fourth step, we will calculate center for all the centroid and reassign the center. Fifth step, we will repeat the step 3 and 4 until the algorithm is finished and we find our final clusters. Now we move on to step 1, where we define k or number of cluster. As we can see from the name itself, k means clustering means we are trying to identify k number of cluster in a dataset. So if you assign k equals to 2, k means clustering will show you two different cluster in the dataset. Whereas if you assign k equals to 5, then we will see 5 different cluster being identified the same algorithm for the same dataset. Like if you can see in this example itself, in this case we can see two different cluster. One is this red cluster and another one is green cluster. So in this data set, if we are trying to run k-means algorithm, we need to run it with the value of k equals to 2. As we can see, two distinct cluster, and then clustering algorithm will return the same cluster. But whereas in a different data set where there are four distinct clusters that we can see from our naked eyes, one is this, one is this, one is this, and the other one is this, we need to apply k equals to 4, which will result in 4 different clusters being identified by the algorithm. Why defining k is such important? As I explained earlier, it is the initial step of the algorithm, and if you make any mistake in a given data set, if you overestimate the value of k, if you say 5 instead of 3 being the right amount of k, then the clustering algorithm will identify 5 different cluster which will cause chaos in the database clustering. As you can see from the example I have shown, so there are one data set in which we can see three distinct cluster. So we can see this one, this one, this one. If we select value of k equals to 3, then the cluster which is generated by k-means algorithm seems to be valid because it matches our what we see from our end goal or from our naked eyes. But for the same data set, if we accidentally select value of k equals to 2, then the cluster are not valid. If you can see, red is assigned for this, it is assigned for this blue. It does not seem like it has done a good job in clustering. So this is the most crucial step. For example, if you overestimated it, so instead of k equals to 3, k equals to 2, if you made it like k equals to 5, then it would have formed one cluster here, 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 total in 5 cluster, which would have caused not invalid cluster being generated, and then it will result in like less accuracy when you are creating your model. So this is why defining the k is most important part of this algorithm. Now that we have defined k or how many clusters that we want to see in our end result, what the algorithm does, it randomly placed the k number of cluster in the data set. So if you can see, we for let's say this given data set, we have three cluster that we can see with human eyes, but k-means clustering algorithm being machine cannot identify it. So what it does is it randomly assign three centroid. So let's say we have a centroid here which got assigned, we have centroid here which got assigned, and then we have a centroid here which got assigned. Again, all this centroid is being assigned because we set the value of k as 3. If it would have value like 4 or 5, then we would have, let's say for example, seen a new centroid here and a new centroid here. So this is how algorithm place random centroids in the data set. Step 3 of the algorithm is, after we assign 3 centroid random centroid in the data set, what algorithm does is for all the points in the data set, so let's say for if we can see in the data set we have all these point as in black, what we do is we identify distance. We can use Euclidean distance or any other distance formula, and we identify distance of that point to all the cluster. So in this case, the for let's say for this point we will identify three distance with respect to three different cluster. So we can see it identify a distance up to red one, it identify another distance which is this one up to green, and then it also identify a distance up to this blue one. And what it does, what the next step is it sorts all the distance and find the nearest cluster. So let's say we can see visually that this point seems to be closest with this centroid, and what algorithm does is after finding the nearest cluster, it assigns that point as that particular cluster. So in this instance, for example, this point which had closest distance to the red cluster is being assigned red. For this is for our visualization. In computer it works a bit differently, but it's a similar thing. It is marked as a part of the red cluster, and it does this step for all the point in the data set. So it repeats this until we have finished all the data points, and at the end what we will see is that all the data point in the data set would be assigned to any of three particular cluster. So we can see this is assigned to red, this is assigned to green because this might have been closest distance to green, these all are assigned to blue, these all are assigned to green. So note that in this instance we can see that clustering algorithm is trying to identify or generate a new pattern, but it is not valid. So this is definitely not valid. We still have some instance of green, but the major thing is it is assigning all the data set to a particular cluster in our data. In step 4, since we have assigned all the data set to a particular cluster, the next step that algorithm does is, based on all the group, it tried to find the centroid of all the data set assigned to that particular group. What I mean by that is, let's say we had initially we had green here, and we had all this data point assigned to this particular green. But what algorithm does is it tries to calculate the center of all the assigned um, point in the data set. So in this example, the center will be this one, and what our algorithm does is move our previous centroid to the new center of the assigned data set. For example, if you can see in terms of red also, red was here earlier, now we can see a lot of red here. So the average, it takes all this data point, try to calculate a middle center for this data point, and it found it here, and then it reassigned to this new centroid. Same for blue. And what this process does is it will try to make um, centroid as near to the data distribution as possible. So if you can see, it is it is getting close to the cluster that we can see from our naked eyes. So if you can see, it is getting close to this red cluster, the green is getting close to this green cluster, and then blue is getting close to this blue cluster, and these are our new centroid. We have assigned and find a new center for all the assigned dataset. We will repeat step 3 and 4 until we are finished with the algorithm. So if you can see, in the last stage we came up with this 3 centroid. Now these 3 centroid will go to the step 3, in which we will reassign all the point to the new cluster. We identify these are the new point that are assigned to these clusters respectively. We will run the step 4, in which we will find center for all these assigned centroids. So in this example, previous center was here, but we found this red to be a bit in the middle, we found this green to be a bit in the middle, and then we found this blue to be a bit in the middle. So these step continues until they cannot find any middle, or they cannot update the centroid any further. So after that, the algorithm gives an output. So it will have output something like this. So it will have a red cluster, green cluster, and the blue cluster. So these are the steps that were involved in k-means clustering. Now I will give you a visual representation of k-means clustering, and I will explain to you how it works so that you can have much more clarity on the algorithm overall. In order to visualize the k-mean algorithm, I'm using an online tool created by Nefali Harish. It's an awesome tool. I'll link this tool in the description. You can go play with it, but we will step I will explain all the 5 steps involved in it in a visual way using this tool. So the initial step is key assigning the key. For this, the tool is already assigning k equals to 3, so we will start with step 2. In step 2, you can see we already have all this data. Step 2 is assigning centroid to this data. Let's say I assign one centroid here, one blue centroid here, and then one green centroid here. And this is a step 2, in which we assign 3 randomly placed centroid. Click on go. After that, after the centroid is being assigned, it will try to find it will go through all the data set and try to find the nearest centroid and assign this. So you can see, these data set were assigned as a part of red, these were assigned part of green, these were assigned in combination of blue and green because it lies in between blue and green. The next step would be updating the centroid. If I click on that, you will see that the centroid is being um, gone from this to the middle of assigned dataset. Same for green, it moved a bit here because there was a lot of dataset assigned from here. Blue moved here, and then the third step would be reassigning the point. You'll see that when we reassign the point, the issue where it was showing green here is now gone. Now the blue is being properly segregated, red is being properly segregated, and green is properly segregated. We will again repeat the step 4, in which we will update the centroid with finding the center of the new data set. So you can see the blue moved to the center of the data set, green moved to the center of the data set, and red moved to the center of the data set. If you click on reassign point, nothing changes. Update centroid, nothing changes. Try again, nothing changes. And update centroid, nothing changes. As there is no change happening in the data after repeating step 3 and 4, in this point the algorithm will end, and we will see that it has identified 3 distance cluster in very efficient way, in which green, blue, and red. And this is how the overall k-means algorithm works. That we understood all the 5 steps involved with k-means clustering. K-means clustering is not ideal. Even though it's one of the most used and most popular clustering algorithm, there are some issues that k-means clustering has. The first one is we need to know the value of k before starting the algorithm. So it is easier for us to identify value of k or visualize it whenever there are not complex data sets. But identify value of k and assigning it in correct way is a long process. There are multiple method and algorithm that we can use, such as elbow method and other algorithm that we need to use in order to assign the value of k. But it is one of the issue with the k, because if accidentally you place wrong value of k, then whole other process involved after this will be wrong, because at the end of it you will receive invalid cluster. The second and major issue with k-means clustering algorithm is the end clustering depends highly on the placement of initial random seed. Let me show you by visualization. What I mean is, let's say we let's say we choose a cluster. Let's say we choose a cluster here, and cluster here. If you run the algorithm, update centroid, reassign point, update centroid, this is valid. But the thing is, we randomly chose this point, and then it turned out to be a valid cluster at the end of it. But let's say I randomly choose another point, something like this, and this. And if I click on go, update centroid, reassign point, update centroid. For this example also it worked. But for, let's say, if I choose Gaussian mixture, this one, this one, and this one, if I click on go, update centroid, reassign point, update centroid, reassign point, update centroid, reassign point, update centroid. If we go, um, after step 4 and 5, the center is being not changed. So this means that algorithm will ends. But if you can see, there is an error in the clustering, because there is no points in the blue cluster, but there are a lot of points in red cluster. Ideally there should be equal number of distribution of the point, right? So this is one of the major issue with k-means clustering, is the placement or the randomization of the initial seed can cause issue with the uh, clustering at the final. So what we do is we tend to run this iteration multiple time, or we tend to use algorithm like k means plus plus, which is like advancement of k, in which the seeds are not placed randomly, but there is algorithm and a certain step that are followed to place the seed, so that it 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 try to reduce this issue, but it is still there. After that, the other thing is k-means clustering being calculating distance and then being identifying cluster based on that distance. It is ideal for numerical data, but it is not ideal for categorical data. So you cannot find distance between two different classes, let's say dog or cat, but you can find distance between 10 and 9. But you cannot find distance for categorical value like dog, cat, or any other, like um, is it bad or good, so something like that. So this is another limitation of k-means clustering. The other limitation is, since k-means clustering works on the distance and then it accumulates that distance to find the centroid of the center, outliner in the dataset will be very sensitive, because it will ultimately add a lot of data. So let's say you have a proper cluster forming here, but you have an outliner which is like very far. It will affect the whole k-mean clustering algorithm, because the distance for that one outliner might be bigger than other average distance for other. So these are the main issues that k-means clustering has. For watching this video, hopefully this video helped you cleared out all the concept with k-means clustering algorithm. If you have any issue or any confusion in any of the step, or want to ask any question, feel free to leave a comment in this video and I will reply to you as soon as possible. I'll link to all the resources and all the slides in the description, so that it can be easier for you to look into it. But yeah, that's all. Thank you for watching this video. See you in the next one.